Hi, good afternoon, everyone. We're just going to wait a few more moments as more people come into the lobby. Welcome to the webinar today. And just to remind you, this meeting is being recorded. Great, well, we'll get started. So good afternoon, everyone. Thank you for coming today. Welcome to today's webinar, From Data to Decisions, Making the Most of Soil Phosphorus for Sustainable Agriculture. I'm Sophie Cath, Sales and Business Development Manager for Kaywood Agriculture. I'm really thrilled to be chairing this session today. Phosphorus plays a vital role in crop growth, fruit development and yield, but when mismanaged, it can undermine crop performance and contribute to environmental challenges. So today we'll explore what the latest soil, leaf tissue and grain data tells us about phosphorus levels across the UK and how this insight can shape nutrient planning to deliver both productivity and sustainability. We've got a fantastic lineup of expert speakers and panelists for you today who will be providing scientific insights, real-world data and practical strategies to help you make the most of soil phosphorus. So before we begin, here's a quick look at today's agenda. We'll firstly be hearing from NRM's own Dr. Sajjad Awan, who will present the latest data insights from NRM on leaf tissue, soil and grain phosphorus. Following that, Nigel Simpson from Catchment Sensitive Farming will be talking about how we can make better use of phosphate we already have, balancing productivity with protecting our soils and water. Finally, we have 15 minutes allocated for Q&A, where I'll be fielding your questions to our expert panel. Now, this webinar will last no longer than an hour. A few notes on housekeeping as always. Please do submit your questions via the Q&A facility that you'll find at the top of the screen at any time during the webinar. I'll collect these and put them to our panel at the end during that specific session. Now, there is one basis point available for today. So for those who would like a basis point, please put your name and basis number into the chat function, not the Q&A function, please, the chat function at any time during the next 60 minutes. And I mentioned at the beginning, but just to reiterate, this webinar is being recorded. So I'd like to introduce our first speaker and hand over to Dr. Sajjad Awan, Soil and Crop Nutrition Agronomist at NRM. Now, Sajjad's got over 15 years of experience in fertilisers, soil nutrition and agronomy, with a PhD in plant physiology and molecular biology. He played a key role in developing AHDB's Nutrient Management Guide, RB209, which underpins fertiliser recommendations across the UK. His expertise spans soil health, regenerative agriculture and data-driven nutrient management. So thank you, Sajjad, and welcome. And over to you, please.
Hello, thank you, Sophie. Thank you, everyone, for joining us for this very important topic webinar on phosphorus. I'm Sajjad Awan, and today I will be presenting some of the findings that we have from our data, especially from plant tissue, soil, and grain analysis. And towards the end, I will try to summarize the insights that we have learned from the data. Right, okay. Now, why phosphorus matters? Why is it important? Phosphorus is a very key macronutrient element. It's required for plant growth and development. It's part of ATP. And what that means is that that drives the cell growth and development and metabolism. It's also a crucial part for cell division, meaning that actually it's the DNA and RNA which are required for cell division. If phosphorus deficient, cell won't divide. No tissues, no roots, no leaves, no fruits. So that means that the production will be massively impacted. It also, as you can see here on the image here, that it's a part of cell membrane. It lets certain things, certain nutrient elements, ions, to get into the cell and out of the cell, meaning that all the cell translocation happens through phosphorus. It also promotes the cell, the root development. That means that the nutrients can be taken up more efficiently, they're utilized, and improve nutrient use efficiency. A lot of more important things, but due to time, I will move on to the results. Now, first of all, I would like to start with the tissue analysis results. We analyze the cereals and other crop tissues, and this data is for the past 3 years. It's all winter wheat data. And before I go and start presenting my results, I would like to remind people of these graphs. So correlation ones, good graphs, probably you may have seen it lots of times. So you increase one variable on x-axis, for instance, and the other variable also increases, and that is a positive correlation. I mean, some people, they present this as 100. You can also present it as 1. That would be maximum. The other way around would be that you increase one variable, the other variable decreases. That means that there is a negative correlation. Now, just to emphasize on the importance of phosphorus, I thought that I should share with you some of the results from our crop check data. And all of these, rather than showing you 50 or 60 odd of these graphs, what I've done, I've shown them in a table. And what this table shows is the nutrients on X and Y axes. And what I've done, so put these nutrients alongside each other. So if we compared, for instance, nitrogen with nitrogen, you're bound to get 1 or 100%. If we look at the phosphorus results, what it shows is a very strong correlation. Now, you might think that it's only 63%. How is that strong? Actually, this data is so diverse. It comes from so many different parts of the country, across the board, actually, under different management, under different environmental conditions, and it's still giving us nearly 60% of correlation, meaning I would class it as a strong correlation. So that means phosphorus will drive the uptake or utilization of nitrogen in the crop. If we look at others, for instance, phosphorus has got a strong correlation with potassium. Now, just about very similar to nitrogen. Another important one is sulfur. And just to remind people that we had a webinar earlier this year in February where we emphasized on sulfur and the deficiency symptoms appearing in soils and in crop tissue that we identified earlier this year. So if you haven't watched that webinar, I would highly recommend going and watching that one. So you can see all the major macronutrients, most of the major macronutrients, they've got a strong correlation. It's also got, I would say that there is a bit of positive correlation with magnesium and zinc. Just to summarize these results, we shouldn't be looking at, when we do a test, we should not only focus on one particular nutrient. All these nutrients, they interact within the plant. And you've just seen that phosphorus is correlating very strongly with potassium, nitrogen, and sulfur. Similarly, sulfur is very strongly correlated with other nutrient elements. And so hence and forth. So what we need to be doing here is to making sure that we look at the bigger picture, not just one nutrient element. A balance is really important for optimization of utilization and improving the nutrient use efficiency. Right, now this brings me to our next set of results, and these are from soil available phosphorus results. Just to give you a bit of context. The data that I've used for analysis here is the past 5 years data. And that comes from around 170,000 fields. Out of those fields, 120,000 actually come from grass, forage, and silage fields. And the remaining around 50,000 samples, they come from arable fields. The data that I'll be sharing again, that would be standard test, which is pH, pK, and magnesium. And phosphorus is analyzed using Olsen P. Now, this is a typical report that we provide, and this is an example report. What we have is pH, phosphorus, potassium, and magnesium. So we provide the indices as well as milligrams per liter. I think to improve the nutrient use efficiency and to improve margins, one of the more important things, rather than focusing on a larger scale, bigger scale indices, we should be focusing on parts per million or milligram per liter, which is a better indicator. Now, what this report shows here, a range of soil pH going into different cropping system, obviously. But what RB29, which is the national recommendation in the UK, that shows that for arable soils, for arable rotations, you should be targeting pH at 6.7. Anything above or below may compromise the nutrient use efficiency, hence the crop yield and development. For grasslands, the target is 6.2. So the low pH, what it does is that the phosphate in the soil actually binds with iron and aluminium. And at low pH, there will be a reduction in phosphorus availability. On the other hand, if the soil pH is too high, that means that calcium will start reacting and making phosphorus unavailable for the plants to uptake. So maintaining the soil pH is one of the most crucial things to improve your nutrient use efficiency. Okay, so this data, I've laid out all of this data, past 5 years worth of data into different bar charts, and these are frequency distribution charts actually. As you can see along the x-axis, was split into starting at 0 and it goes above 70 milligram per liter. What the results show here is that at index 1, we've got a lot of soils which are actually, these are nearly 31% of the soils are at index 0 and index 1. And these soils, that means that at this point, phosphorus is insufficient, reducing the crop yield. As I mentioned earlier, right at the introduction, if phosphorus is a limiting factor, then the crop yield would be compromised. Index 2 is the main part. This is the target index. This is a recommendation from RB29. They should be targeting at index 2. Now, you can see that at index 2, we've got nearly another around 30% of the soils which are at index 2, whereas a staggering 45% of the soils, they appear to be at index 2 and above. That means that these soils have got way more phosphorus than they should be. So for that, actually, what we need to do is try to reduce. If you've got too high phosphorus, you should be looking into reducing phosphorus. Now, what we've done, all that data actually shown on the English map. The reason I'm only showing here England and Wales is that a lot of samples that I've shown earlier, 170,000 samples, originated from these regions. Now, what this map from arable rotation shows that there is quite a big range from index 1.4 average, these are averages, in 1.4 all the way to 2.6. And you can see on the northeastern side of the region, we've got the lowest index, and on the opposite of that, on the northwestern side, we have got the highest of phosphorus index. The obvious reasons, a lot of these areas in the northeast are actually arable rotations, probably limited number of animals on farm, whereas on these regions, northwestern side of the region, there is a lot of dairy farming, which explains that the indices are really high. Further to that, you can also see that the eastern, southeastern, and the West Midlands have got quite a high indices. We should be aiming, targeting at index 2. So arable soils are actually being maintained slightly above index 2. Now, if we look at the grassland, now we can see that the picture is very similar, but the range is now changed slightly. The northeastern region still has got the lowest index, and the opposite to that, northwestern side has got the highest of the index, whereas the eastern side has got slightly just above. But most of the other regions, as you can see, because this is a regional basis, remember, the overall picture is that we are very close to index 2, but not quite. So we need to be focusing on targeting at index 2. And just to remind that all the recommendations are based on the middle of P index 2, which is around 19 to 22 milligram per liter. Now, to further focus on these regions, rather looking at the whole country, we have got these 3 regions. We selected these 3 regions. The reason behind that is that a vast majority of the samples actually originated from here. And for data purposes, for higher confidence, we decided that we look into these 3 regions: the east of England, southeast of England, and southwest. As we know, most of the soils in the eastern and southeastern regions, they have got predominantly have got arable rotation. So we're focusing on this region, these regions. I'm just going to share the data for the soils for arable rotations. Now, if you're not familiar with these graphs here, this is a box plot showing whiskers here. Whiskers are the ranges, 0 to 59 milligram per liter. The mean here is shown as a cross here, and the median is 24. So 24 is very close to the top of index 2. That means that index 2 goes up to 25 milligram per liter. That means that we are, the median set at 24, very close, very high. If we further zoomed into this data, what it shows that only around 20% of the soils, they are below the target index. Around a third of the soils, they are actually at the target index. And this is the best part. So around 11% of the soils, they are bang on where the recommendations originate from. And nearly half of the soils, they are well above the target index. Here, in these conditions, we should be aiming to run down. Whereas if you are towards the lower end, you should be building up your phosphorus levels by applying slightly more than the crop offtake. Moving on to the grass for silage. And now, as I said earlier, that the focus would be in the southwestern region, because a lot of samples that were received from grass silage, they came from this region, southwestern part. The range is between 4 and 49 milligram per liter with a median of 19. If we further zoomed into the data, what it shows that a lot of soils, 35% of the soils, they need to be focusing on applying more and building up, try to build up your target levels to be somewhere around this region, the middle of index 2, middle of target index 2. Around a similar sort of number is higher. So there is a lot of difference between, so a lot of people could have been here, but actually they are on both ends. If you're higher than target index 2, you should be aiming to not applying any more phosphorus, but try to reduce using the offtakes. And if we look at the grass for grazing, the picture is not too dissimilar. The range is slightly bigger, as you can see, 0 to 54 compared to 4 to 49. The median is exactly the same, which is 19 milligram per liter. If we look at the picture here for the grazing fields, where they're solely used for grazing, 37% of the fields well below the target index. That means that we should be building up, because the grass quality and the quantity would be impacted if we are low from the target index. Around, I would say, 30%, another third belong to the middle, which is target index, but only 9 which are bang on where they're required to be, and another 35% are above. These people should be aiming to run down. So a lot of differences between the soils, and a lot of these soils actually they are towards both ends rather than in the middle, the target index. Now, just to remind people that where we are, what the key messages are from this data set. The low P soils, if you are index 0 to index 1, you should be building back up with extra phosphorus application, and there should be a rigorous monitoring. It does not mean that actually you cannot have good quality yield for not just for the cereals, also for arables, or just and for also grass. You can, there is evidence that you can maintain higher index 1, but you got to be having rigorous monitoring, soil testing, tissue testing, grain testing, and having a proper handle on your management. If you're at target index 2, you are in the best place. You should be replacing the offtakes and maintain a balance. And if you're high P, you should be aiming to reduce the target index, reduce the index, and bring it down to target index 2. And this is the soil data. Now, this is the last set of data sets about grain phosphorus. This is really interesting data, actually. There are a couple of slides only. From winter wheat. So all the data originated from winter wheat, analyzed between 2021 and 2024. So 21 to 24 harvests, actually. And there are 4,000 samples in this data set that I've used. I'm only going to focus on phosphorus. As you can see that the phosphorus, in terms of phosphorus, 59% of the samples, they have turned out to be low at target phosphorus level. RB29 suggests 0.32% grain phosphorus for winter wheat. Now, if I would have 0.32 only, I would be looking at nearly 75 or 80% of the sample below the target value, 0.32. So, because looking at the data, if I further zoom in into the individual years, this is a very busy graph, but let me open it up slightly. So this is the year 2021, this solid line here, peak. And this one here is 2022, this graph here. What they show is that 2021 had a low yield, 7.8 ton per hectare, compared to year 2022, which was 8.6 ton per hectare. If you look at the two peaks, they are furthest apart. So this is 2021 and this is 2022, the furthest apart. And you can see that every time you have got yield increase, there is a decrease in phosphorus concentration. That means there is a dilution effect as the yield increased, the grain phosphorus concentration decreased. And as you can also see from this data set, that none of the years that we analyzed so far, we only got 4 years data, we have not been able to get to 0.32 as the peak or the median. So it suggests that the recommendations in RB29 may need to be reviewed. 2024 is an odd year out. It was very wet, one of the wettest years actually on record. If you remember 2023, October until March 2024, it just rained. And the crop establishment was really poor. And I believe that that could be a contributing factor towards a higher concentration because of the yield and the number of grains per spike. Just to summarize this data, the grain test provides a post-mortem. I always call that if you really want to understand what's going on in your individual field, you should be aiming to look into grain test. That would give you a really important picture. In the subsequent years, you should be able to see what's going on. And for correction during the next growing seasons, it's really vital. And that's what we should be aiming for. Very quickly to summarize, soil phosphorus, we should be aiming to maintain between 19 to 22 milligram per liter, but target index is between 16 to 25, but this is ideal, 90 to 25. The tests should be used. They should not just be taken and put away in the folders or in the computers, but they should be utilized to improve the efficiency, to improve the performance, and to optimize yield and to reduce waste, and also to minimize environmental risks. With that, I would hand back over to Sophie, and thank you for listening.
Thank you, Sajad. It's always very insightful to see that breakdown of the data. Just to remind everyone before I introduce our next speaker, now's a really good time to pop some questions into the Q&A function. I can see a couple there already, which we will address later on the webinar, but please do pop your questions in there if you've got any. So to introduce our next speaker, I'd like to hand over to Nigel Simpson from Catchment Sensitive Farming. So Nigel joined CSF in 2006 when it first started, leading the team of advisors in East Anglia for 15 years and delivering advice, training and countryside stewardship to farmers. And since 2021, he's been part of the CSF national team, training the next generation of farm advisors to reduce air and water pollution. He's a member of the International Fertiliser Society and also previously worked as an agricultural consultant, helping to edit RB209 and writing reports, including use of farmyard manures. Great to have you here, Nigel, today. So over to you, please.
Thank you very much, Sophie. Well, my title today is Phosphate, Making Better Use of What We've Got. So I'm hoping that that's going to be relevant to all of you. In relation to catchment sensitive farming and providing some context, we work in England to keep our air and water clean, to reduce flooding, and by giving voluntary advice and support to farmers and land managers to help their businesses be more efficient and economic by minimising losses to the environment. And by making good use of your resources and preserving those resources is why I'm giving this talk today. So it's relevant to all farms, but my talk is mainly reflecting my experience of phosphate use in England. Phosphorus is an essential element for all of life. It's the chemical, P is the chemical symbol for the element, but P is often used as a briefer term for talking about phosphate and phosphorus. Elemental P is too reactive to occur in nature. It spontaneously ignites and can thus be used in munitions, but not as a fertilizer. It's mainly found in phosphate compounds, which have various chemical formulae. Fertilizer phosphate, you may know, was sometimes described as having P2O5 as its molecular formula, but that does not exist. If you have to calculate P from, say, an analysis either of grain, manures, or other things to phosphate, then you have to multiply by 2.29 in order to do so. And that will then help you be more consistent in doing calculations. In relation to the phosphate cycle, this is something that I've picked off the internet, which gives you a diagram of that. And phosphate will, as it were, be available in various forms in soils, as well as in manures, fertilizers and crop residues, and can be in particulate matter in runoff. There is a soil solution of phosphate which is available, and that represents only about 0.2% of the total P in your soils, and that varies according to pH, with the soil solution interacting in various ways with other organisms and with regards to leaching, immobilization, and so on. And so it's taken into crops in relation and microorganisms in relation to that soil solution. And it will then interact in a sort of two-way street in various ways between these various forms in the soil. And as you may see from the diagram on the right, the pH affects the availability. Now, since that diagram was done in 2005, and I've referenced it there, it's been shown that, in fact, at pH 6.5 in mineral soils to pH 7, we get 95 to 100% availability of phosphate. But when you get down to pH 6 on a mineral soil, you'll find that maybe 52% is available. And that was in a basis classroom study that we did on phosphate recently, up to 70% at pH 7.5. So it varies in terms of how it absorbs and reacts with calcium, aluminium, and iron in relation to pH. There's also an effect of phosphate on water quality, because as water temperatures rise, then you can get algal blooms, green algae, which can be toxic and later deoxygenate as the water temperatures drop in the autumn. And that then is because as the algae die, they take oxygen from the water. And you can sometimes see that green coloration in lakes and ponds and in other standing waters. But good water quality is recognized if you've got below 0.2 milligrams per litre of what's called orthophosphate. It's sometimes called soluble reactive phosphate or dissolved phosphate, but that's only half the amount that then causes loss of small microscopic algal organisms called diatoms, which worldwide produce something like 25% of our air oxygen. And those diatoms are something on which to plankton feed, amongst other things. And that then provides food for invertebrates and then fish. So if we harm that biodiversity and food chains, then we can also harm the livelihoods of fishermen and anglers, as well as farmers who manage watercourses and lakes for angling. So it's not a good thing, obviously, to have too much P in our fresh waters. As it so happens, in marine waters, nitrogen is more of an issue in relation to algal blooms. Particulate phosphate occurs on soil particles, and that can become sediment in water, and it's often brought to watercourses and lakes by runoff and erosion. And we can see that turbid water, as we have in that picture there, in the River Stiffkey in Norfolk, on the right-hand side of your screens. And in 2006, it was estimated that we lose roughly 2 million tonnes of soil and organic matter per year across England and Wales to water. And again, a reference there to that report. And on sloping fields, 80% of phosphate can be lost by runoff or erosion on clay fields, whereas on sandy loams, it tends to be more like 20% because clay more strongly absorbs phosphate onto it. It's not inevitable that we lose soil from farms to water. We can reduce those losses by erosion. We can use a soil management plan. We can put in grassed areas and bunds, beetle banks, sediment ponds and silt traps, trees and hedgerows, plant tram lines, and on row crops. And we can use a tool called a dammer diker if you've got the actual tram lines there, or an ackwheel if you're using beds, or other tram line disruption. As well as we can improve soil organic matter by minimal cultivations, timing of operations, and by changing our land use. And each year in catchment sensitive farming, we record the uptake of such practices and measures on which CSF have advised, and we estimate the benefits from farmers' efforts and uptake of that advice. And here's a picture of what that looked like back in 2018. We are just about to do a new evaluation report, and that will update these figures, but it shows that we made a bigger difference in East Anglia and certain other areas of the country to what they have had in some areas as we speak. But that's all modelled based on the uptake of the advice that I've given earlier. Sometimes we have useful suggestions also that might help you in terms of if you can improve infiltration by maintaining field drains, you reduce compaction, you reduce peat burning, you use spring cultivations, you retain overwintered stubbles, use low ground pressure tyres, and avoid organic matter at times of high runoff risk, then you can try and reduce the phosphate losses. Again, by not applying P to high index soils and areas, then that will again help reduce those losses. By use of a nutrient management plan and high risk of, and if where there is a high risk of runoff, you avoid poaching and reduce the grazing season, use buffers and convert arable areas to grass. It's not about doing everything everywhere, but please, can we do the right thing in the right place that meets your needs? Environmental losses are also economic losses. About 44% of our arable land, some 2 million hectares, is prone to erosion. And even drained land can have turbid water flow through what's called crack flow. And by using minimum cultivations, you can reduce those losses that attach to particulates in that drainage water. So such soil losses can also potentially increase the need for extra phosphatic fertilizers. And that seems like a perverse ask in a way, because that land has already demonstrated its inability to hold on to what was there. So applying more P could increase economic losses in a vicious circle, as well as causing increased environmental harm. The risks we face, something like 4 million hectares of England and Wales are at risk of compaction, reducing crop rooting and potentially increasing the need for readily available phosphate for crops. So by following good practice, we can protect our resources and get the best from our inputs to match crop need. And to illustrate that, I've got a slide here which shows that actually where the Environment Agency has done some modelling, where the darker blue actually reflects those areas where losses from agriculture and farms is greatest, then you can see that there is variation across the country in terms of the threat that losses from farms can pose, mainly linked to those indices that Sajad showed earlier, along with the slopes. So the lower losses tend to be on less slopy ground, or where you've got lower indices. But having said that, I've superimposed there some water courses with red and orange and yellow, showing where those problems are worse in terms of surface water qualities, but that often links to losses from sewage treatment works. Agriculture contributes roughly 26% or 28% of the losses of phosphate to water. So why do soil analyses? It's required under farming rules for water every 5 years. More frequent testing may be beneficial if you've got intensively used grass and high value arable crops. And ideally, if you can do it at the field level, then that's so much better than doing it at a farm level. But if you've got varied soils or varied histories within the soil or the fields, then smaller areas and even grid sampling can be beneficial. We're all familiar with use of GPS fertilizer spreaders, and increasingly that will help people where they've got that variation. What we want to do is match soil nutrients to crop and soil needs, and that looks at what's available to the crop and provides then the expected yield and quality that we wish for, as well as delivering nutrient use efficiency, optimizing the economics and sustainable production in future. As Sajad mentioned earlier, we can find that it takes a while to build levels back up if you've run them down too far. It's not all about soil chemistry, though. Soil health is actually something that we need to think about, not just the nutrients and pH, but soil organic matter. And the physical health links to soil texture and soil structure, and that often will link with soil organic matter. And if we can also think that soil organic matter reduces compaction and capping, then it all sort of helps things along the right way. There is a soil health card that you can download from the AHDB website. And you can also think about soil biology here, because earthworms and fungal life, many microorganisms actually do link not just to the soil organic matter, but actually will use that as the sort of carbon engine for their lives. So it does all work together for good. And by knowing your soil nutrient levels, we can manage applications to minimize nutrient losses to water or running off into ditches and thus losing money again. I would also encourage people who don't yet do it to get analyses for the organic materials, because we do need representative samples with sufficient replication to see what's in it, because otherwise it's really a guess. And published results, such as those in RB209 booklet 2, are averages, which will not reflect your actual nutrients and what they're worth when you either import or export organic materials. And given that fertilizers are a considerable cost, currently nitrogen's worth about £1.14 a kilo and phosphate £1.14 a kilo as well. So coincidentally, you can see that there's a lot of value potentially in those organic manures when you multiply by the amounts that are spread. And we believe that something like 90 million tonnes of organic materials are spread on farms each year. So you can see it comes to a lot of money. I can't interpret the results from the yield enhancement network, but what Sajad said about grain analyses is also helpful if you want to look at if your fertilizers are matching to crop offtakes, because relatively few grain samples do show the correct crop nutrition, and phosphate often shows up as below the threshold of concern. In other words, not enough is in the grain for optimum yield and quality. Having said that, the PUs provided by grain and other tissue analysis is retrospective, but soil analyses for P-index is predictive, and we therefore wish to avoid the problem in the first place if we can. And so I'm going to ask if we can each have a coordinated and long-term strategic approach to crop nutrition, which links the organic manures to what we've got in the way of records, yields, and so on, and essentially makes best use of the organic and inorganic nutrients, and we innovate as we learn more. On-gate nitrogen balances and phosphate balances are another way to help you, and CSF advisors can potentially help you by commissioning a specialist visit on such balances. And it's most useful on livestock farms because, as you may know, livestock feed is very often rich in both nitrogen, as in crude protein, and in terms of phosphate. And that actually then results in very often a surplus on livestock farms and in livestock manures to what you might wish for, in terms of to the point where you probably do not need to be applying much in the way of those nutrients to your crops, particularly for grazing and so on. You will need extra nutrients for some silage crops, particularly if you do multi-cuts. Such N&P balances enable you to see if your nutrient management practices are correct over time, but lower annual excesses mean that there's been more efficient use of our N&P. So to sum up, you will find that progress is beyond what we used to do. There is a HDB report called RR93, and you can look that up on the HDB website, which looked at the use of phosphorus in arable crops by Ian Richards. But we all need to be coherent and effective to achieve the goals that we have to meet our needs. So my challenge today is, can we balance our N&P inputs to reduce losses to water, improve biodiversity, and support farm and crop production? Does anything else need changing? Well, if we look at efficiency, then if we see how much has been applied for crop yield and quality targets and then see what was taken off, we can then look at our soil pH to see that it's optimal, the soil structure to see that there's good rooting, and then soil health and tillage practices match, again, what will produce optimum yields. And then by improving your management and skills, we will get the best out of these soil analyses, manures and fertilizers when and what is applied. If we're wanting to check that we're getting the P balance right, then you can do that on a field by field basis. You can even do it in each part of the field if you've got the software to do it. And by reducing losses in sediment and nutrient runoff, maybe by using cover crops, buffers, grassed up valley features, and so on, as well as reducing what's called subsurface flow, which is what goes below the soil surface, then we can, again, hopefully get the best results and do, if you like, a better job than now. So I'll finish with just suggesting that if you wish to know more about catchment sensitive farming, you can go to that link that I've put in the slide there, and it will take you to the relevant pages on the .gov website that will enable you to find your local providers. Okay, thank you very much, Sophie.
Thank you, Nigel. That was really insightful. So I'd now like to introduce our panelists. So we have, firstly, Ali Arden joining us, agronomy manager at NRM with over 20 years of experience in agronomy, including 2 decades as company agronomist at CF Fertilisers. And he now supports advisors and farmers on manure management, soil health planning and sustainable land management. We then have Sean Stevenson, Director of Product for Agriculture at Kaywood. With a degree in biochemistry, Sean's been with the laboratory business for around 25 years, holding senior roles across both operations and commercial functions. So his breadth of expertise brings a unique perspective on how laboratory analysis and innovation can support the industry. And finally, I'd like to introduce John Davies, Senior Advisor for Agriculture at the Environment Agency. And John has over 20 years experience in farm inspections and agricultural advice, and since 2021 has provided technical support on farm regulation across the UK. A qualified agronomist, he has a particular interest in soils and nutrient management, and is registered with both the BASIS Professional Register and the BASIS Environmental Advisors Register. So I'm sure you'll agree, a great panel to have today. So I see that we have a few questions that have come into the chat. Please keep them coming. So I'll start with the first one, which is from Duncan. Thank you for your questions. So question being, is there any data to suggest the regional variations of available P in Scotland? The image is great to see, but would be interested to see one from Scotland if available. I think that's probably best for you, Sean, and also just like to maybe link into that. There is a difference in methodology from Scotland, so it'd be great if you could explain that to the viewers.
No problem. Thank you very much, Sophie, and thanks for the question, Duncan, and thanks for joining the webinar. The majority of samples that NRM deals with mainly come from England and Northern Ireland. Sophie and I would like us to have more from Scotland. I think the majority of the samples we do get from Scotland are associated with precision farming companies, so we don't tend to have information as in terms of location of those farms or cropping to then allow Sajad to look at that that data. So unfortunately, we probably don't have that data for Scotland. Maybe the SRUC or the labs in there, that might be something that they might have. And then I'm just going back to Sophie's question on method. Yeah, the methods in England and Northern Ireland are different to Scotland. That's mainly due to the sort of pH of the soils in general. In England and Northern Ireland, we've maybe got more neutral to alkaline soils, so we use an Olsen extraction method for the phosphorus, sodium bicarbonate, which tends to be more alkaline, to sort of more closely mimic what might be happening in the soil solution in those soils. And then in Scotland, it's modified Morgan's. It's a more acidic extraction because the soils are generally neutral to acidic, so that hopefully is more representative of the soils in that region. So that hopefully that answers that question, Sophie.
I think so. Take that. Thanks, Sean. Moving on to Tom's question around saying, interesting to see the grass for grazing, but do you have a similar slide covering silage grass areas for comparison? I'll pass that to you, Sajad, as that was your slides.
Yeah, thank you, Tom, for asking that question. Yes, we do have data, and I have displayed some of the information on there, but I take your point. I can follow this back later on. We can display this on regional basis. That's not a problem. Thank you.
Okay, great. Moving on to this question. Will phosphate vulnerable zones be brought in similar to MVZ? I think, Nigel, that might be best for you.
Well, up to a point. The honest answer is there are things similar to this in Northern Ireland, where they do have particularly problems with Loch Ness and other areas. But by the same token, at the moment, as far as I know, there is no plans within DEFRA to bring in phosphate vulnerable zones. Having said that, the very reason that I gave this talk is to try and avoid such a thing happening. So if we can do a better job about reducing those losses from farms, then there'll be no need to bring in regulations to help us improve farm practice.
Thanks, Nigel. Perhaps, John, do you have anything to further add on that sort of thing?
I think just to add to what Nigel said, really, as far as I'm aware, that would be a decision for DEFRA, but and government. But as Nigel suggested, if we can do things perhaps a little bit better than we are doing now, and if people, plan nutrient applications and manage phosphorus in the best way that we possibly can, then I think, there should be no real reason why we need to go down that route of legislation.
For sure. And I mean, I'm sure most farmers are doing their absolute best. But whilst you're on, John, are there any kind of key common areas of non-compliance that are found during farming rules for water inspections?
Yeah, I think, when we actually look at the data we've got, and I think we've got inspection data from over 17,000 farm inspections now, there's one area of the farming rules for water that consistently keeps the biggest area of non-compliance, and that is in relation to Rule 1, which is all about nutrient management planning and soil testing. And the data we've got shows that around 30 to 35% of farmers and land managers probably haven't got sufficient in the way of either soil testing results and or nutrient management planning evidence to demonstrate compliance. So I think it's a relatively easy win that if we can nudge the industry along in terms of getting a bit better at nutrient management planning and getting soils tested and interpreting that data, then we'll go a long way to improve compliance with that particular part of the regulations.
Well, that's certainly music to our ears, John. So yeah, thank you for that. Moving on to Graham's question. This is probably one for you, Ali. How could soil P be run down on a sandy soil, currently 5+, when pH is 7.5?
Thanks, Sophie, for the easy question. Thanks, Graham. Yeah, it's pretty tricky if you've got a situation where the total sort of soil pool is large, but of that pool, you've only got quite a small proportion which is ever going to be available for the crop to access. So in those situations, it's really difficult to sort of mine that P because the crop can't physically remove it out of the system. So I'm sort of guessing it's all about minimizing inputs. And if you're finding in those situations that, you may or may not see a response because the available pool is so small that you end up sort of, using products that deliver very small amounts of P at drilling, for example, you're placing P, but it's difficult when you're being signed off on an index. At index 5, you shouldn't really be putting any inputs on at all. So I guess it's how we can solubilize this total pool so the crop can get access to it. Don't know whether anyone else on the panel has got any view on the easiest way of doing that. No.
Nigel, go for it.
Nigel.
Right, well, just to say, you're absolutely right that by not applying P, you will over time run the phosphate status down, and the better the crops yields and the more phosphate they need, the better you will run that down. If you can also minimize those soil losses by erosion and leaching and drainage that I've mentioned earlier, then again, that will help you keep the soil in the field in the right place and minimize the detrimental effect that it might have on water and wildlife. So by the same token, it might take you 20 years of nil P applications with high yielding crops to get it down to maybe what's the target index of 3 if you're growing veg, and maybe 30 years if you're looking at a target index of 2. But it can be done over time. And there's the question, how much time have you got?
Great way to end that answer. Moving on to Carolyn's question, do different tillage methods have any effect on P levels? I'll pass that to you, John, and then perhaps we can move to one of the other members of the panel if we've got time.
I was saying, I don't know whether I'm actually the correct person for this one, to be honest with you. I mean, I think I might have to defer that one, I'm afraid, to somebody who knows a bit more about cultivations than I do.
Let's move that to Ali.
Yeah, well, I think this is quite an important one because when we get samples in from NRM, more often than not, we don't know the cultivations, we don't know the sample depth. And there is very clear guidance about if you're ploughing versus if you're minimal cultivation about the sample depth. And when Sajid and I have been looking at all this data and looking to see these very high values on some of the more arable counties, we sort of wondered to ourselves whether some of these had been sampled at the wrong depth, because you do end up stratifying nutrients if you're not careful. So yeah, you must sort of sample 23 centimetres if you're not ploughing, and if you're ploughing, sampling to the traditional 15 centimetres, and that those are related then to the index. So it's quite important that when you are going out that you do sample to the right depths. And in a grassland situation, remember that if it's permanent pasture, you're sampling to your traditional 7.5 centimetres. But if you're reseeding, then you do have to sample a bit deeper to 15 centimetres because you're mixing that soil up. So it is important, and I do think that we might be receiving some samples in that have not been sampled to the correct depth. So that's something to think about when you're getting out this autumn, when the weather's nice this week.
Great advice. And this perhaps partly links, but maybe one for you, Nigel, from Fiona. Would a focus on root health / establishment help?
Certainly, again, if you can imagine that tillage will affect the establishment of a crop, both in terms of speed and establishment and vigour, as well as rooting depth and so on, then it all can have linkage to the level of P that's both taken up by the crops and therefore extracted in terms of offtake. But I also see that Sean's got his hand up.
Oh no, that's someone. Just a reminder, if you've got a question, just easier to fill out via the Q&A function. Thank you. And then just the final question from Mark. High pH and high P soils. Just really the main question is around, can you get a soil test result from total P and available P? Probably best for you, Sean, that question.
Yeah, thanks. So yeah, we can do total analysis of nutrients. So certainly that's something we do. Maybe obviously not at the same regularity as the available, but it's something we can do. So if you're interested in that and getting some details, please contact our the commercial team, Sophie and her team at NRM.
Brilliant. Thanks, Sean. Well, we've got 1 minute to go, so I think it's best to close off for today. So just wanted to thank you all so much for joining us, and particularly thank you to our speakers and panelists. Hope you found this insightful today. And just a quick reminder, if you haven't already, there is a basis point available. So if you would like to claim it, please pop that into the chat function, your name and basis number. And again, to reiterate, this has been recorded and we will send a link out afterwards, so you'll be able to re-watch this or share with colleagues On behalf of NRM, Captain Sensitive Farming and the Environment Agency, thank you so much again for your time and participation, and have a great rest of the day.
Bye, everyone.
Thank you.
Bye.
Thank you.
Bye-bye.
Bye.
Bye-bye.